So center of mass completely we have done. Now we are talking about the second topic of this chapter, that's called conservation of what? Momentum. And later we will talk about the application of them, which is generally used in what? Collision problems. Okay, so we will see collision. Now let's talk first what is conservation of the momentum. So definitions you are learning from many chapters. Okay, so you say that when there is a system is there and no net external force is acting on the system, then the momentum of that system is what? Conserved. This simply comes from what? Newton's third law only, right? Newton's third law talk about what? Conservation of the momentum only, right? Yes. So I'm writing definition here. When no net external force acts, then the momentum of the system will be conserved, or you say what? Constant, right? When net external force is what? Zero. No net external force is acting, then the momentum of that system will be conserved, means the total initial momentum will be equal to what? Total final momentum. And when I say system, you cannot consider like one body alone. Suppose you have a ball and you drop it to the floor, correct? Then you should say that the momentum of ball plus floor together will be conserved. You cannot say that only ball momentum will be conserved or only floor will be conserved. That's not possible. You talk of the whole system. Suppose you have two balls, and this ball of mass 1 m2, right, and they collide, right? Suppose they collide, right? Then you cannot say that the momentum of this body alone conserved or this body alone conserved. No, you have to say what? Whole system. Whole system is these two bodies together, the momentum will be conserved. Initial momentum will be equal to what? Final momentum always. So we always say that suppose initially they are at rest. Okay, suppose you say, how you say, okay, what is the momentum of this ball? Let's say moving with velocity v1, this moving with velocity v2. No. So you say that like p1, you say p1 vector plus p2 vector should be what? Constant or what? Conserved. That's the law says. Okay, when no net external force is acting, then total momentum should be constant. So look here, what is momentum? m1 v1, right, okay, plus m2 v2 should be what? Constant. Yes, let's differentiate this equation. If you differentiate, what you will see? So you say the m1 dv1 by dt plus m2 dv by d2, right, is equal to what? Okay, you are differentiating this term. So differentiation here, mass is constant and velocity is variable. I wrote it here. This side is a constant, and constant differentiation is always what? 0. So that term becomes what? 0. Now look here, this is what? m1 a1, this is what? m2 a2 is equal to what? 0. And ma is nothing but the force f1 plus force f2. ma, the force applied by this body, it is what? Force of this body. So net force is 0. It means what? Momentum is what? Conserved. So these two things are what? Like we have already learned in Newton's third law. What do you say? If you say net external force acting on a body is 0, then the momentum of the system will be conserved, right? Yes. Okay. Now what you have to do in this topic, you have to see a few, we will talk about 5-6 a few like questions which are repeatedly they ask in our NEET exam. So we will talk one by one all of them. So first most famous problem is what? Your recoiling of gun, or you say gun and bullet problem. Okay, we'll see what type of questions are asked. Okay, so suppose you have a gun, right? So that's your gun, and you fire a bullet from this gun, right? Gun of mass m, okay, and bullet of mass what? Small m. So you know that bullet will move in this direction with velocity say small v, and gun will recoil backward with velocity what? V. Why it recoils? To keep the momentum conserved, because initial momentum of the gun plus bullet both are at rest, so it's 0. Suppose I talk initial momentum, then gun will be 0 because gun is not moving at rest, and bullet also at rest 0. So both momentum is what? 0. It means final momentum should be also 0. And how to make final momentum 0? If one body is moving that direction, then other body should move in that direction, opposite. Otherwise you cannot make net momentum 0. Correct? Okay. So final, when you talk, you say again momentum of the gun plus momentum of the bullet should be again equal to what? Initial momentum, which is what? Here 0 only, right? Okay, what is gun momentum? We're writing capital M into V. Correct. Any one direction you call positive, this is the momentum of this, then momentum of that bullet will be this much. So this should be equal to what? Initial, which is what? 0. So from here, the first question what they asked to you, they call the recoil speed or velocity of gun. Okay, simple question they can ask like that. Thus velocity you have to calculate V. So V will be nothing but what? Simply mv upon what? Capital M, and negative coming here. Why negative coming? That the direction of velocity of recoil of the gun will be opposite to the bullet, right? Actually in real, why I am writing this we writing according to what? Our that rule only, vector addition rule. Momentum is a vector. If you want to add any two momentum, you have to write the same formula only. Which formula? Any two vector you want to add in physics, you have only one formula, a square b square plus 2ab cos theta. We will see some more use of this in this lecture, okay? Yeah, so first question they asked that what is the recoil velocity or recoil speed of the gun, right? Yes. Okay. Second question they can ask you here, that who has more kinetic energy? Who has what? More kinetic energy, bullet or gun? Who has what? More kinetic energy, right? Yes. So who has more kinetic energy, bullet or gun? Momentum they have equal, we know, right now. Yes, momentum is equal and opposite. To make net momentum 0, this should be equal to what? That to make what? 0, right? Now listen carefully. We know how momentum and kinetic energy are related. If you don't know, I am writing here. You know momentum formula is what? Just mv, and kinetic energy just I am writing E symbol. So E is equal to what? Half m into what? V square. So let's convert kinetic energy into momentum format. Hope you already know. So what you do? Multiply this equation by m and divide by m. So we get energy is equal to, look here, this become m square, v square, that become p square by what? 2m. Thus kinetic energy in terms of momentum, or momentum in terms of kinetic energy will be P will be equal to root 2m into what? E, right? So momentum in terms of kinetic energy, or kinetic energy in terms of what? Momentum. Okay, so question was here that who has more kinetic energy, right? Here what we know only one thing. We know that these two guys, gun and bullet, has exactly same momentum. Momentum is same. So look at this equation. From this equation, you said energy is equal to what? Kinetic energy is equal to what? P square upon what? 2m, right? Momentum of both is same. 2 is a constant. So you see that kinetic energy is inversely proportional to what? Mass of that body. The body which has smaller mass will be having higher kinetic energy, right? So who has small mass here? Obviously the bullet, correct? So energy, kinetic energy and moment mass in this case are what? Inversely proportional, right? When momentum is same, then only, okay? Yes, otherwise if you see the formula, that will look like kinetic energy proportional to what? Mass, correct? Na? Yes, so here momentum is same. We don't know about velocities. Momentum we know that should be exactly same. So from here we are telling that kinetic energy and mass will be inversely proportional. It means what? It means what? Bullet, which is smaller mass, has more kinetic energy than what? Gun. Correct? Yes. So this is about what? Kinetic energy. But net momentum will be what? 0 only, because initially both are at rest. Now you fire, and you firing because of again internal energy or internal chemical energy, right? Or forces, right? So no external force is acting. So momentum of the system is what? Conserved. Okay? Yes. Okay. So this is what your gun and bullet problem. Let's move on to second type of problem, that's called bomb explosion at rest. Like in last topic we have discussed center of mass, that suppose center of mass is not affected by what? Internal forces. So I gave an example like a bomb is placed at ground and now it blasts into 1,000 pieces, and they ask you where is the center of mass of all these pieces combined. Then what is the answer? It remains on the ground only, because initially it was at rest and is blasting because of internal forces. So the center of mass will not change, position will not change. It was at rest, it remains at rest, or it was keep moving like a projectile, it keep moving. Okay. So what happens? Here similar questions are asked, and this question was asked many times in our exam, repeated in our NEET exam. They say there is a bomb and is placed here of some mass, right? M. Now it explodes into 2 pieces, 3 pieces, any number of pieces given. Suppose 2 pieces are given, then it always will happen that 1 piece goes here, then 1 piece will go in opposite direction always. Why? Because initial momentum 0, like this case only, final momentum should be also 0. So 0 is possible if you have two bodies that have what equal and opposite momentum, right? So if two pieces they say, nowadays they don't ask two pieces, they are asking three pieces only, but let's talk. Suppose it blasts into two pieces, right? This m1, this m2, this was mass m, this is moving with velocity v1, that's moving velocity v2, correct? That's momentum you calling p1, that you calling p2. We know that initial momentum is what? 0. This bomb was at rest, this at rest. So initial momentum 0 means total final momentum should be also 0, which is nothing but what? m1 v1 vector, this is one momentum, m2 v2 vector, this is a final. So p final should be equal to what? P initial. So you can equate to 0 and find some unknown, like same, what's the velocity of anyone, or they can ask you who has more kinetic energy, who has more velocity, like that, okay? Yes. But mainly you talk about three pieces problem which they ask in our exam nowadays, okay? Three piece problem we'll talk. Suppose this is a bomb. Okay, actually this question also you are answering by vector rule, but it's just when you have two simple pieces like this way, then they always move in opposite direction, so directly you can answer them, okay? Because in this formula, when you put like these are two bodies moving at what angle? You say at what? 180 degree angle, right? So you want to add the momentum p1 and p2, so what it comes? p1 square plus p2 square plus 2p1 p2 and cos 180. Cos 180 is what? Minus 1. So how the formula come? Like p1 square, simply like a square b square minus 2ab, which become a minus b whole square and root. So answer becomes simply a minus b. Correct now? So that's why you can write directly. Okay, so this is placed at rest and now it blasts into a few pieces, like this a piece 1 goes here, piece 1 goes here, and piece goes third goes here. This is m1, m2 and what? m3 and velocity v1, v2 and what? v, right? Initially it was at rest of mass m, correct? Now when three pieces are given, definitely they will give angle between any two pieces, otherwise you cannot solve this problem. So 3 times they have asked in our exam, all the time they gave here 90 degree, but any angle can be given here, right? Yes. So look here. What happened? Initial momentum should be what? 0, because bomb was at rest. Initial momentum 0. The final net momentum should be what? Again 0. So the sum of the momentum of the three pieces which are calling p1, p2 and what? p3. So you say that final momentum, which is nothing but p1 vector plus p2 vector plus p3 vector, right? This should be equal to what? Initial means this should be equal to 0, correct? So what will happen? Always angle between what? Two pieces will be given to you 100%, right? So what do you say in this formula? If you equate, like you say that p initial is equal to p final, then what are you getting? Saying p1 vector plus p2 vector plus p3 vector should be equal to what? 0, correct? So what you will do? Something will be unknown. Generally third piece, what? Some value will be unknown, either mass or what? Velocity, okay? Mass given, then velocity they will ask you, velocity given, then mass they will ask you. So first what you do, like p1, p2, these angle between these two is given, then what you can say, like p3 should be vector simply equal to what? Minus of p1 vector plus what? p2 vector. This you have to do always. Means what you will do, first you add the momentum of these two pieces, correct na? By vector rule, that formula, root a square b square plus 2ab cos theta, whatever angle given here, then this should be equal to the momentum of the third piece. Means like m3 v3 should be equal to what? Sum of the momentum of these two. We will get our answer, unknown answer here, right? This step you have to follow always. You take the sum of the two momentum whose in two pieces whose angle is given to you. Angle will be given. Then we see that the momentum of third piece should be equal to sum of these two pieces. That coming p3 should be equal to what? Vector sum of, this is a vector sum, okay? p1 plus p2, and we will get the unknown thing here. We will do now numerical on this, how they ask, okay? Okay, let's see this example based on what? Explosion of the bombs, right? Yes. So look at the first problem. 1 kg bomb which is stationary, it explode into what? 3 pieces, okay? Yes. Of mass ratio 1, 1 ratio 3, right? Mass ratio given. Parts having the same mass moves perpendicular to each other with velocity of what? 30 meter per second. Find the velocity of the third piece. So this type of question was asked 3 times in our NEET exam, okay? Very, very important pattern. So let's solve this problem. So initially your bomb was here of mass 1 kg, it was at rest. Now it exploded into 3 pieces, 1 piece here, 1 piece here, and say 1 piece what here. M1, correct? This is what M2, this is what your M3. Listen carefully. They said that two pieces having same mass, means those having ratio 1, they move perpendicular. Say these two mass moving perpendicular. Okay, let's find mass also. Look here. Mass ratio is given what? M1, say M2 and M3 ratio what is given? 1 ratio 1 ratio what? 3. Correct. So what is the mass of the first piece? Either you want to call directly, like you can call it 1 kg, this you can call 1 kg, that you can call 3 kg, that also work. But if you want to write in terms of like 1 kg you want to write, okay, then how you write? Okay, what is the mass of first piece? One part, out of total part, 1 plus what? 3. That becomes what? 4, 5 into what? 1 kg, right? That's the mass. So it becomes what? 1 by 5 kg. That's also M2 also, same mass. And what is M3? M3 will be 3 part, right? 3 part of total 1 plus 2 plus what? 3, 5 of what? 1 kg become what? 3 by 5 kg. You can find these things, right? So these are the mass things. Now, mass we know. So they're saying what's the velocity of the third piece? So this is momentum P1, P2 and what? P3. Initial momentum was 0, P initial 0, P final should be also 0 and P final is what? P1 plus P2 plus P3. There are 3 particles, you have to take vector sum of them. So initial is equal to final, you can equate to 0, we have to find P3 things. So P3 vector should be equal to what? P1 vector plus what? P2 vector. So first we have to find what is P1 and P2, then we have to take their vector sum. So what is P1? M1 V1, right? Mass of the first piece how much we found? Is what? 1 by 5 kg and velocity is already given. How much given? 30. So you write 30 here. That becomes what? 6. And P2 also what? Same, because mass same, velocity same. These two pieces having exactly same mass and same velocity. Now let's take the vector sum of these two. So what is the resultant vector? You know, R is equal to nothing root a square b square plus 2ab cos theta. A square means P1. P1 is how much? 6. 6 square. P2 square. Let me write formula if you confuse. P1 square plus P2 square plus 2 times P1 P2 cos of the this is a formula to add any two vector. Okay, what is P1? Means what? 6. 6 square plus 6 square plus 2 times of 6 into 6 and cos what? 90. Cos 90 means whole term is what? 0. Cos 90 means what? 0, right? Okay. So this we have root 6 and root 6. You can write simply is what? 6 root 2. Okay. Yeah. That's your momentum. Sum of these two momentum. Now this should be equal to what? P3. So it means P3. I'm writing here again. P3 should be equal to what? 6 root 2 and P3 is what? M3 V3. M3, what is mass? Mass we know is what? 3 by 5 into velocity V3 we have to calculate 6 root 2. Correct? Okay, this goes 2 times. So this answer becomes V3 becomes simply 10 root 2 meter per second, same units. This is how they ask mainly in our exam. Okay, exploration of the bump problem, conservation of momentum principle we writing. Okay, yes. So mainly it was asked like this way 3 times. Then look at the next problem, this type of questions, like a bomb initially at rest again explode into what? 3 pieces, equal pieces. Okay, all mass are equal. The velocity of 2 pieces are given 2i plus 3j and minus i minus 4j. Find the velocity of the third piece. Correct. So this problem we are talking here. So 3 pieces are the blasting, initial at rest, so initial momentum was 0, the final momentum which are 3 pieces means P1 vector plus P2 vector plus P3 vector, this should be also equal to what? 0. We have to find velocity of the third piece, so P3 let's calculate. So again P3 should be equal to what? Minus P1 plus what? P2 vector, okay. Here also minus coming, like but numerically we writing, so just we writing 10 root 2, otherwise minus comes here, okay. Now, okay, mass, let's write momentum. So mass of everybody is given same, let's say m into what? V3 vector is equal to minus m into V2 vector, m into what? V1 vector. Okay, this P1, okay, I should try like V1 and V2. So mass you can cancel first because given same. Now V3 is simply equal to minus V1 vector plus V2 vector. So minus V1 is given what? 3i plus 2j plus V2 is given what? Minus i minus 4. Minus I minus 4j. So that comes how much? V3 simply comes how much? Minus outside. This becomes 3i means what? 2i. And that becomes what? Minus 2j. Then you take that minus inside becomes minus 2i plus what? 2j. That's the velocity of the third piece. If they ask in vector form, this is your answer. If they ask as a magnitude, then it will be 2 square plus 2 square. Right? 2 root 2 you can write. Right? Hope you understood this. Okay. Let's see next problem. So this is in vector form. Third problem. So these two problems, I said like bomb is what? Stationary, okay. Now here it was moving. Moving means initial momentum will not be 0. There will be some initial momentum that you have to calculate, but final momentum will be equal to again initial momentum only, okay. Yeah. So read this question. There is a bomb of 1 kg mass thrown vertically upward. We thrown some bomb what upward with initial velocity of what 100 meter per second. It explode into two pieces at time is equal to what? After what time? 5 seconds once we throw, right. First part of mass 400 gram moves downward with velocity of what? 25 meter per second. Find the velocity and direction of the second piece. Correct? Very interesting problem. So look here. So this was, you have thrown something from ground here, and when it reaches some height here, after 5 seconds they are saying this explode into two pieces. One piece moves downward, obviously one piece should move what? Upward, correct, or it can move anywhere. Generally two pieces means they always move in what? Opposite direction, okay. So two equal pieces are given, right? No, pieces are not equal. So the piece which is moving downward is given 400 gram. This is given 400 gram. Then the piece which is moving up will be 1 kg minus 400 means what? 600 gram, obviously, right? And this was 1 kg initially. Correct? 1 kg bomb, it was moving, it was in motion and explode into what? Two pieces. We have to calculate what? The velocity of the second piece. Okay, the velocity of this piece is given. Okay, let's calculate what is initial momentum. This is important. First, calculate initial momentum is not 0. Like these were at bombs at rest, so initial momentum was 0. So final also 0. But here initial momentum is there because the ball is moving, the bomb is moving. Okay, let's calculate momentum. So we need to calculate when it's about to explode at this point, what's the velocity of this bomb. Initial velocity is given what? 100 to you. What's the velocity at that point? So let's write equation of motion for that. We know what time. So V is equal to what? U plus what? AT, correct? This we can write because you know acceleration, we know what time. So V is equal to what? U minus GT. Acceleration I am writing what? G, and negative G, because when you are moving upward your acceleration will be minus G. If you come along towards center of earth is positive. So what is the final velocity? Initial is given 100, minus G is 10, and time is given 5 seconds. So this becomes what? 50 meter per second. It means what? When the bomb is exploding here, the initial momentum that we are finding will be what? M we will be writing. Mass is given 1 kg, okay, done, and velocity is what? 50. So 50, this is what your initial momentum, correct? Yeah. When the you can write unit if you want, right? Newton second, doesn't matter, okay. 50 is the initial momentum. So final momentum of these two pieces should be also what? 50. Okay, so final momentum we are calling like P1 plus P2, correct, this momentum. And listen carefully. So these two are moving in opposite direction. Again, two momentum we have, P1, P2, we have to add them by vector rule only, P1 and P2, let's say. And what's the angle between them? What? 180 degree. How they are moving? 180 degree, opposite to each other. So when you add by vector rules, like here you put P1 plus P2 plus 2 P1 P2 cos 180, it becomes what? P1 plus P1 square plus P2 square minus 2 P1 P2, or simply answer becomes like P1 minus P2, correct? No? Yes. Okay. So same thing I'm writing here. So let's say like P1 minus P2, that's the final momentum, okay. I have added them by vector rules. P1 upward, P2 downward, angle is what? 180 degree, then answer becomes P1 minus P2 after vector addition. Should be equal to initial momentum. Initial momentum already we have calculated, which is what? 50. Okay. So P1 minus P2 should be equal to what? 50. This is a final momentum, that's the initial momentum. Okay, what is P1? Momentum of what? This guy. Okay. That mass is what? 0.6 kg, 600 gram, and velocity we don't know, we have to calculate, minus the momentum of that piece. Mass is 0.4 kg and velocity of this piece was given somewhere 25 is equal to what? 50, correct? Okay, let's see. So 0.6 into V3, okay, this term come on this side becomes 50 plus 25 into 0.4, how much that comes? So if you multiply this 4, it becomes 100, so it becomes what? 10, so it becomes what? 60, correct? So V3 will be what? V3 will be equal to 60 by 0.6, means it becomes what? 100 meter per second. That's your answer. The second piece will be moving what? this piece which is moving upward will move at what speed? It moves at 100 meter per second, correct? Yeah. So in this case the bomb was moving, so it has initial momentum. So you have to calculate an initial momentum, it should be equal to what? Final momentum. In these two cases the bomb was initially at rest, so initial momentum was 0. So you calculated final momentum is equal to what? Initial 0, right? Okay, so these were the problems on what? Explosion of the bomb. Okay, now we'll see problem based on what, like bullet and block problem. Like pendulum is there, a bullet comes and hit that pendulum, the pendulum will rise to some height. We have to calculate some answer like what's the height rise, what's the angle made by string, what's the velocity, and all these questions we'll do now. Okay. Okay, before going to the bullet and the block problem, let's talk about spring problem. Okay. Third type of problem we're doing on conservation of momentum. Spring and to block problem. Okay. Just like gun and bullet only. So here what happens? There will be two blocks, same mass m1, connected by a spring m2 of spring constant k. So this spring is either initially compressed or it was expanded. Okay. Either it's compressed or what? Expanded. So initially what happened? Spring is either compressed or you say expanded. Okay, any one thing, right? Any one thing. So suppose compressed. Okay, like this. Now you leave the block, so block will move. Suppose they are compressed, then block will move in what? Opposite direction, like this one, right? This moves velocity v1, this moves with what? Velocity v2. Or they were expanded, again they moves what? Opposite to each other, like they will come, try to come like that way, right? Yes. So now what happens? So here what question they will ask you? Again these things only. Velocity of any one piece is given, other piece they will ask to you. Okay. Or they can ask you who has more kinetic energy, who has more velocity, right? So listen fairly. So initially, because there is compressed or expanded, they are at rest. So initial momentum we call P initial will be what again? 0 only. So final momentum when you write of these, that should be also what? 0. Final momentum P, final first will be what? P1 vector plus what? P2 vector. This I am calling P1, that I am calling what? P2, right? So the sum of these two should be again what? 0. So when write that P1 vector plus P2 vector should be what? 0 only. So also now when you add this by vector rules, again this is P1, P2 and angle is what? 180 degree. Again answer becomes what? P1 minus P2. It means what? Your P1 should be equal to what? Minus P2. That's all, right? Yes. So suppose velocity of any one is known, like m1 v1 is equal to what? m2 v2 and negative sign here always. Yes. So any one velocity is unknown, that you can find from this relation. Very simple relation, right? Velocity of first piece is given, velocity of second piece they are asking. Yes, you can calculate from here, right? Okay. So one question they can ask you velocity of any piece. Then other they can ask you who has more kinetic energy, right? Who has more kinetic energy? So again I said here momentum of both pieces are equal and opposite. So kinetic energy, again you talk in terms of momentum P square upon 2m, just like we did for gun and bullet. P is same for all. So kinetic energy again inversely proportional to what? Mass of the body, right? Correct. So suppose they are asking kinetic energy of this piece, this one by this two ratio they are, then because what? Inversely proportional. So that becomes mass of the second piece by mass of the first piece, right? This will be the ratio of their kinetic energy. And who has more depends on their masses, right? Small the mass, more the kinetic energy, right? So this is a very simple type of question. Let me give an example. Like this type of question was asked to us, that two blocks with a compressed spring are released as shown in the figure. Find velocity v2 and ratio of their kinetic energy, right? So some picture is given to you. They say two blocks are there, initially they were compressed, spring was compressed and now you leave them, so they start moving with some velocities. So this block is given 5 kg, that block is given say 2 kg, and velocity of this piece was given, v1 was given, this moving at 10 meter per second, and this moving this direction velocity v2, this k is given, some value may be given, we don't need that, okay. Yes, so they are asking that what is the velocity of v2 and the ratio of their kinetic energy of these two pieces. This piece has kinetic energy e1 and momentum p1, thus has e2 and momentum what, p2, correct. Okay. Okay, first job. Initial momentum is what, 0. P initial what, 0. P final should be also 0, which is nothing but p1 vector plus p2 vector, right? This is the momentum. So simply p1 vector should be equal to what, minus p2 vector, because they are moving in opposite direction. Angle between them is what, 180 degree. We are adding this momentum again by vector rule, root a square b square plus 2ab cos, okay, 180. So this answer becomes like a minus b simply, okay. Yes, so what is momentum of the first piece, m1 v1, so that's given 5 into what, 10, correct, 5 kg into velocity given. Then second guy, mass is given 2 and velocity v2 we have to calculate, correct. So you calculate here, then you see that v2 becomes simply 25 meter per second, and negative sign is coming, means moving in opposite direction, that's all, okay. Yes, now you have to write what is the ratio of their kinetic energies, right. Okay, so because same formula will use that kinetic energy is equal to p square upon 2m, because momentum they have exactly equal, 2 is constant, energy depends on mass. So energy of the first piece by second piece means this mass by that mass should be equal to what, m2 by what, m1. So m2 means this, which is given 2 kg, and that is given what, 5 kg. So this is your ratio answer, okay. E1 ratio E2 should be equal to what, 2 ratio what, 5. Suppose what happens now, one additional thing. They said the total kinetic energy of the system is given to you at any point, okay. If total kinetic energy is given, then they can ask you what is kinetic energy of this piece and that piece. You can do like half mv square that way also, or if you know this ratio, you can find from here also. That's your choice, right? So very simple question they ask based on spring, like, okay.